Hello everyone, how are you all? I hope and you all are doing very good and I wish that you should be at your best very soon. So hope you all are enjoying and learning very well using this previous year question series that we are creating for you. We have already created all playlists on electricity, magnetic effects, light and human and colorful world chapter, and we are solving previous year questions of all chapters parallelly. So we request you to go to our channel and watch our playlist and enjoy the education. So here I brought one more question to you that was asked on the chapter magnetic effects of electric current and based on the concept force on a charge, right? So let a question goes like this: a uniform magnetic field exists in the plane of paper as shown in the diagram. In the field, an electron and a proton enters as shown. The electron and the positron experiences forces, option A, both pointing into the plane of the paper, option B, both pointing out of the plane of the paper, pointing into the plane of the paper and pointing out of the plane of the paper respectively, and pointing out of the plane of the paper and into the plane of the paper respectively. So here, to answer this question, we should be knowing Fleming's left hand rule. What Fleming's left hand rule states? Fleming's left hand rule states when forefinger, middle finger and thumb are placed mutually perpendicular to each other like this, like this, like this, like this, are placed mutually perpendicular to each other, then the forefinger should be pointing the direction of magnetic field and middle finger should be pointing the direction of current. And when these two are aligned to the direction of magnetic field and current, then thumb will be pointing the direction of force, right? So one major precaution that we need to take here is about the middle finger. Middle finger should be pointing the direction of conventional current, not the electron current. Okay. So now if you look at here, electron is moving down means it is electron current direction. We have to take the direction of the conventional current. Conventional current means opposite to the direction of motion of electron. So let us align these two fingers now. So how is the magnetic field from left to right? So magnetic field from left to right pointed. Okay, sir. Now electron is moving down means current will be moving up. So this finger represents the direction of current and current should be taken in the direction of conventional current. So it went like this, right? So now where is thumb pointing? You can look at the thumb is pointing towards the paper or towards the page. You all can do this experiment. See, magnetic field left, correct, and see electron coming down means current is going up. Current is going up. So where is the thumb now? Thumb is downside. See thumb is here. Thumb is downside. So the force is acting on the electron towards the page. And the same is applicable for proton also. See, for proton is moving up means positive charged particle. The current should be taken in the same direction of positive charged particle. So middle finger is should be pointed up only, and the magnetic field is also not changing for proton. It is moving from left to right only. And then where is the thumb? Thumb is pointing down only. So for the both electron and proton, the force is both pointing into the plane of the paper. Okay. How to remember this one? You can remember this one as F and M and C. How? See, F. F means what? You can remember it as father. Father will be the strongest person in home. So which is the strongest finger you have? Thumb. So F. And if you look at these two, M stands for mother, C stands for child. Sometimes if you look at, children will be taller than mother, correct? So this is children current and M mother magnetic field. So these three if you place like this, you are going to get, and you can apply this rule on any condition. Okay. Thank you. We'll meet in the next video very soon.